So in 2005, BCA was commissioned by the Wildlife Conservation Society to assess the conditions, prepare the documents, and monitor the repairs and rehabilitation of the Italian Rockefeller Fountain. The goal of the rehabilitation was to curtail the deterioration of the fountain, replace severely eroded features, while upgrading plumbing and electrical systems to contemporary standards. Part of the funding of this rehabilitation came from a Save America's Treasures grant. Despite the SAT grant, the funding was limited, and so was the duration for the rehabilitation. Since the fountain is a work of art, as well as a city landmark, both the Design Commission of the City of New York, as well as the New York City Landmarks Preservation Commission, were involved in the rehabilitation. Under our direction, electrical, plumbing, lighting, waterproofing consultants were brought in to help with the assessment and recommendations. Besides the entities mentioned, the fountain required the involvement of the restoration contractors as well as stone carvers. The Italian fountain's rehabilitation, despite its modest size, required the collaboration of many. Michelle?
Oops, did I press the wrong button? I think I was. Oh no, sorry. Oops. The Bronx Zoo was founded in 1895 as New York Zoological Park, and Rockefeller's Italian fountain has always been part of the zoo's historic core. This 1986 aerial view depicts the fountain in its current location in a circular plaza north of the historic Baird Court. It's right there. Baird Court is now known as Astor Court, for anyone familiar with the Bronx Zoo. Baird Court was designed by New York architects Hines and Lafarge as the centerpiece of the new zoological park. The court originally consisted of 5 detached brick and limestone neoclassical animal houses and a central sea lion pool on a raised and landscaped terrace, which you can see here. This image from about 1880 shows the fountain in its original location by Lake Como in northern Italy on the Piazza Cavour. The Piazza Cavour was created in 1860 from landfill as a gathering spot for tourists and local residents. In 1872, wealthy Como businessman Sebastiano Mondolfo commissioned local sculptor Biagio Catella to create the fountain for the piazza. From the beginning, the design had its critics. Some objected to the use of sea creatures instead of freshwater animals that would have been found in the lake. Some felt that the swan at the top of the fountain looked rather like a goose, an observation that turned out to be prophetic. In addition, the fountain was not designed to recycle water. Instead, it served as a source of fresh drinking water by drawing from a local aqueduct, thus causing hardship for other smaller local fountains using the same source. After less than 20 years on the piazza, the fountain started to lean. The city deemed the repair too expensive and placed the fountain in storage where it remained for 10 years. That's the city of Como, by the way. In 1901, after a devastating fire and fiscal mismanagement, the cash-strapped Como sold the fountain to a local resident, who in turn sold it 1 year later to an agent for William Rockefeller, co-founder of Standard Oil and wealthy philanthropist. And Rockefeller was doing the same thing that was happening at Vizcaya, where he was collecting treasures from Europe and reusing them here. Rockefeller purchased the fountain as a gift for the new zoological park. Rockefeller's fountain was originally placed in Baird Court opposite the sea lion pool, and when the fountain was erected on Baird Court, the large concrete basin was added beneath the fountain. This image from about 1907 depicts the fountain in its first location at the zoo, with the sea lion pool just visible at the right. In 1910, the fountain was moved to its present location, the circular plaza that we showed you in the first slide, at the north of the court, which opened up space on the court for the construction of a new animal house. In its location on the plaza, the fountain serves as a prominent focal point in transition from the zoo's entrance to Astor Court. This view from about 1912 shows the fountain shortly after its relocation to the circular plaza. In 1968, the Italian fountain was designated one of New York City's first individual landmarks. Como has attempted to repatriate the fountain twice, in 1968 and in 1993. The City of New York turned down both requests on the grounds that the fountain was purchased legally and is a New York City landmark.
The fountain is composed of 3 limestone and granite tiers, rising above a large circular concrete basin with a low granite curb. The top tier is composed of a circular platform topped by the figure of a swan, with its long neck stretched upwards. The rim of the middle basin is ornamented with, and hope you're happy to hear this, Carol, 4 grotesque cast iron masks, each centered between the scallop shell groups. The middle basin is half the diameter of the lower basin and is round with a scalloped rim. The upper basin contains 20 low relief grotesque masks which are carved beneath each scallop on the rim. 4 naiads or merpeople are mounted on rusticated stone piers in the concrete basin. Each naiad supports a large scallop shell overhead, and putti ride mystical seahorses. Archival sources identified the stone used for the fountain to be either an Istrian marble or Bianco P marble. The granite is not specifically named. Our analysis of the stone indicated that the fountain was carved from limestone and not marble. A thin section of the stone was prepared and examined under polarized light microscopy. As seen in the top figure, which shows abundant fossils of various forms that are cemented primarily with calcite spar typical of limestone. In contrast, the bottom image shows marble at the same magnification and shows a texture very different from the sample from the Italian fountain, particularly the larger grains and intimate grain contact that are typical of marbles. The limestone had eroded at the neck and the bill of the swan, probably exacerbated by freezing water coming out of the mouth. The copper water supply tube in the swan's neck could be seen through the eroded hole. Staining, erosion, and biogrowth were found throughout the fountain. Large cracks were visible on the mushroom-shaped pedestal on the left slide. On the right, the underside of the mushroom pedestal was extensively eroded. These images show the deterioration of the underside of the top basin. Sculptural elements were falling off and details of the 20 masks were eroding. Friable and many contained cracks likely caused by the freezing water around the funnels going through the masks. This is a detail of dolphins showing a network of cracks out the snout and previous repair that had failed, as evidenced by the metal pins that were corroding. Note the cracks radiating from the pins. Yeah, they're right here. The bottom jaw of the dolphins had spalled off. Water supply copper tubing was exposed. Erosion and biogrowth was found on the limestone. Extensive cracks, such as the one at the center of the shell, would have progressively worsened if left untreated. The seahorse was missing its lower jaw. You can see it. The detail of the merman exemplified vein erosion of the limestone throughout the fountain. This is a view of the mermaid with similar erosion and biological growth. The mermaid was missing some fingers on her right hand, and the left hand was either a reattachment or a Dutchman replacement. Detail of erosion at the nose and lips, staining and carbon soiling under the scallop shell can be seen. The image of the sculptural figures in the low and middle basins show that the merman was missing a section of its tail. Previous repairs included a staple pin, as you can see on the right slide, right in here. Repair at the seahorse's tail. There were spalls to the tips of the scalloped shells. This puto and seahorse were heavily soiled and covered in biological growth. The bottom jaw of the seahorse had spalled and needed to be repaired using a new stone Dutchman. Cracks had developed into the incipient spalls as seen on the right side of the puto's face, and shows that sedimentary stone deteriorates by exfoliation. This is a view of the top basin and shows that the concave funnel drains that had failed waterproofing campaigns. A copper alloy staple pin is visible on the cementitious basin liner. The face of the mask at the bottom of the screen had fallen off. This is one of the fat. Despite the previous repair attempts. Detail of one of 4 cast iron masks on the middle basin show extensive green stains exist from the biological growth. The corroding metal is staining the granite. A tube in the mouth of the mask allows water to drain from the middle basin. The side profile of the mask revealed gaps between the masks and granite, allowing bird nest and water to sit. The removal of the cast iron mask revealed the various episodes of anchors, which were still extant. You can also see the open and very wide mortar joints throughout. The cementitious parging of the middle basin had extensive cracks. As mentioned, in particular at the cast iron mask locations, we could see plant growth in some joints and cracks. Detail of the drain showed an ineffective makeshift corroding screen sieve. The open joints and ineffective basin liners allowed water to flow out of the basin and into the underside of the fountain. Underneath the fountain is a valve pit room where most of the plumbing lines were. Due to all the cracks in the basins and plumbing lines, the valve pit room was under several feet of water, as you could see in the wall, and as you could see in the walls were lined with lime deposits from the mortar joints that had been deteriorating for many years. We performed testing program to see the most effective, least harmful method of cleaning the fountain. Water misting was found to remove the biogrowth and general soiling from the limestone surfaces. Areas containing heavy soiling were cleaned using a 2-part chemical cleaning system. Granite surfaces were cleaned with a chemical cleaner, and areas that contained heavy lime deposits and staining were cleaned using a microabrasive cleaning system using a vortex-type nozzle. The media was crushed glass. Deeply embedded ferrous stains were removed using chemical cleaner and poultices. All the mortar joints were repointed. Due to the friable condition of some of the limestone features, all limestone surfaces were consolidated after they were cleaned. The areas of limestone that were consolidated were covered to prevent them from getting dirtied and oversprayed while other areas were being consolidated. Also, many of the repairs had to cease during the winter months. You could see the snow underground. The manhole entrance to the valve pit room is visible on the bottom of the slide. A limestone supply from Indiana was found to be a good match to the existing limestone. This stone was used for most unique, non-repetitive, severely eroded sections or stone features. A custom colored cementitious patch were developed to repair minor holes and cracks. And that's what you can see from the slide below, different patching colors. Due to the limited budget and time constraints, we opted to use cast stone instead of carved stone to replace severely eroded sections that were repetitive. These dental-like wedge sections were replaced with cast stone. Cracks were not systemic and were repaired to prevent further deterioration, expansion, and water infiltration. New and previous surface cracks were repaired by injecting with epoxy resin and filling surfaces of cracks with composite patching material. Open veins were grouted, as mentioned in the previous lecture, with dispersed hydraulic lime. The black and white view on top right is an early photo of the 20 masks. The level of weathering amongst the faces was mostly uniform with the exception of a few faces, that had cracked or in one case had been lost completely. Our approach was to replace the face that was completely missing and conserve the rest. Conservation entailed resculpting of minor features that were completely missing using composite patching materials, patching cracks, reattaching loose sections using epoxy, removal of inappropriate repairs, and stone consolidation. The intention of the restoration work was to maintain and conserve the existing weathered but even appearance of the faces. A few stone units were carved out to match the limestone to replace the missing face. The replacement unit was carved to match an existing unit whose profile was the most articulated, but also maintained the weathered appearance of the ensemble of 20 faces and did not strive to achieve an as-new condition. All new lead funnels and internal pipes were fabricated and installed. The eroded swan's neck and head were replaced with a new carved limestone. We removed paint samples from 2 cast iron masks and brought them to our laboratory for analysis. The goal was to determine, if possible, the original finish of the masks, as determined through analysis of paint chronologies. The paint analysis revealed that there were 11 layers of paint on the cast iron masks. The original finish was found to be a metallic bronze-colored paint. After the removal of all corrosion, scaling down to bare metal, the masks were painted on both sides with a rust-inhibitive coating primer, followed by a base coat and a final coat to match the original finish. Masks were reinstalled with new stainless steel anchors, and sealant was installed between restored cast iron masks and granite surfaces. Here's a view of the finished mask. View of the upper basin shows that the cementitious liner was replaced with a new reinforced polyester waterproofing membrane. The funnels going through the 20 masks were also flashed with the membrane to create a seamless liner. The color of the membrane was selected to match the stone color as closely as possible.
Let's see, can you guys hear me without the microphone?
Yeah.
All right, because I like to maybe